Hello my dear student, today I am going to explain formation of image by a convex lens. It will be benefited for the class 8 also 10. This is the basic thing for standard 12 to study optics. So formation of image by convex lens, I am considering first situation that the object is placed at infinity. So let us consider first of all, you have to draw a convex lens. You can see this is a convex lens. Okay, my dear student, it is convex lens. And you have to draw a straight line that will be as a principal axis. It is the principal axis of the lens, and divide the lens from the central part, and you will get here the meeting point is O, that is called as optical center. This is termed as optical center. Now as we know that light ray is coming from infinity, object is placed at infinity, and when the object is at infinity, the light will come from the infinity to the lens, from the object to the lens, then only image is formed. And if light is coming from infinity, then all the light rays will be parallel amongst themselves. जितने भी लाइट रे होंगे वो सब आपस में पैरेलल होंगे. So we are considering here first light ray. You will use a scale to draw the light ray diagram. So this is the light ray coming from infinity, which is parallel to the principal axis, as well as I am considering two light ray. These two light ray are parallel to each other with the among themselves as well as with this principal axis. So what will happen, as you know that if light is coming from infinity parallel to the principal axis, it will pass through the focus after refraction. So after refraction it will pass through the focus point. This is the focus. The lens has two focus. One is first principal focus, other is second principal focus. So I am not going to confuse you both the side. If your object is kept this side, left side, the focus will be on the right side. If you take the object on right side, the focus will be left side. And altogether we will consider two focus. So here the light ray is passing through the focus, and from this side it will also pass through the focus, and therefore both the light ray are meeting at the focus. So image will be formed at this focus point, focus of this convex lens. So what is the position of object? I am writing here in short. Position of object, it is at infinity. What is the position of image? Position of image, you will write in full. Position of image on focus. So what is the nature of image? Nature of image, you can see the image is formed due to the actual meeting of the refracted ray. If there is actual meeting of the light ray, then the image will be real. So image will be real, and real image is always inverted. So we can write here real and inverted. Real and inverted. So what is the size of image? We can write here SOI means size of image. This is point size. Point sized, or you can say very small. Very small. So by drawing, if you will be given the question, in question the position of image object will be given, and you have to draw the ray diagram, and you have to write the nature, position and size. So likewise you will always use to write this thing. Now come to the second situation. Second situation is position of object between infinity and twice of the focal length. Here side is infinity, this is the twice of the focal length, f1 to f1, f2 to f2. As I have told you that there are two principal focus, left side and right side. So it is taken beyond 2f, you can say beyond 2f also, or between infinity and twice of focal length. So I have taken AB is the object, here AB is object, this is object, and mind it, light will come from object only. So light and you have to select at least two light rays. So first light ray is taken parallel to the principal axis, and after reflection it will pass through the focus of the lens. Now the light ray is passing through the optical center, so it will pass throughout and it will meet at this point. So we can draw here a line where it is cutting, so this will be the object. So you can say this is of image A1 B1. A1 B1 is image. A1 B1 is image formed by this lens. So where the refracted light ray meets and they meets there, the image will be formed. So A1 B1 is the image formed. Now looking over this ray diagram, you can write nature of image. You can see it is inverted and it is formed due to the actual intersection. So it is the real and inverted. Size of image, you can say, see, AB is larger than A1 B1. So A1 B1 is image which is smaller than the object. So we can write here size is smaller than object. Smaller than object. What is the position of image? You can see between F and 2F. So you can write here between F and 2F. If according to figure, if you want to write, then you can write F2 and 2F2. But it is focus and twice of focus. So between F and 2F you can write. So this is the situation according to the given question. Now we will consider the third situation. In this case we will put the object on F. We will put the object on F. On F. Then what changes will come? Let us see. Now object is on F or on focus. If the object is placed on focus, what will happen? Here we have to eliminate this line. So this is the situation. I have taken the object AB on 2F. Here on 2F. On 2F. Question is on 2F. On twice of focal length. Twice of focal length. So on 2F. So we will consider again two light rays, one parallel to the principal axis and other will pass through the optical center. So it will pass throughout and goes beyond it. So it will goes beyond that. and if we draw it, we will see here the image is formed at 2f2 at the other side. You can see 2f2. I have drawn here with a free hand. So this is the ray diagram. Now we can write here position of image on 2f other side, on 2f other side, nature of image, again it is real and inverted, size of image, it will be same to the object. You can see, if you draw using a scale, you will see the size of AB is equal to size of A1 B1, both will be same, so size will be same here. So you can draw using the scale and pencil. Similarly others can be drawn. So I am going to now explain the formation of image by this convex lens when object is placed between optical center and focus. That is the special situation, a special case in which a virtual image will be found. Here is the situation, position of object between optical center and f1 focus. So here is the object, AB is object placed between optical center and focus. A light ray will pass through the optical center, it will pass throughout, and parallel light ray, it is passing through the focus of the second side, and you can see that these two light ray is moving away from each other, so they will not meet at this side. That is why it is enlarged backward and it is meeting at this point. So the image is formed here. Here is the image. A1 B1 is the image here. AB is object and A1 B1 is image, which is, you can write here position of image, position, nature of image, and size of image. You have to write these three things. So position, you cannot say that the position is between focus and optical center. It is virtual, it is shown in the figure here, but its position may be here, may be anywhere behind this object. So position is in the same side of object. You cannot say it is on focus, it is beyond focus, or it is between focus and optical center. It is at the side behind object, in the side of object, and nature of image as it is made by proceeding the lines, so it is virtual. So it is virtual, and as it is virtual, so it will be erect. So it is erect, virtual and erect. Size is larger than the object. This situation is further termed as simple microscope. This situation of the object, with to see the object we are using convex lens. So it is, in this situation we are calling this lens as magnifying glass, or it is also called as simple microscope. To see the small object we are using microscope. So if we put the small object between focus and optical center, it will appear very larger, and we will see from other side its size will be larger. So it magnifies, it enlarges the size of the image. So it is also magnifying, situation of magnifying glass. Now come to formation of image by a concave lens, and the situation is that the object is at infinity. So this is the concave lens, and this is the principal axis x1. Divide this lens, you will get here O optical center. As the object is at infinity, so light ray will come parallel to each other from infinity, and to form the image we should take at least 2 light rays. So we are taking here 2 light rays, and as it diverges, diverging lens, so it will diverge along this direction. So these two will not meet there. So by proceeding it in backward direction, we will get the image on focus. Image will be here. As we know that all the parallel light ray in the concave lens, it appears to diverge from the focus. So it is on the focus, image will be formed on focus. So position of image will be on focus, size of image will be very small, point sized or very small. Nature of image will be virtual, as it is formed due to the virtual intersection of the 2 refracted light rays. So virtual and erect. Real is inverted and virtual is always erect. Similarly, we can consider the second situation, that the point object is placed between infinity, and object is between infinity and O. Infinity and O. If we consider this in the second situation, if we consider this point, what will happen? Let us see by drawing the ray diagram. So we have taken object between infinity and O. O is here and infinity is there. So AB is, this is the object taken in this case. So we will take 2 light rays parallel to the principal axis and other passing through the optical center, which will pass throughout this. So this light ray will diverge out along this direction. So these two will not meet, and by proceeding it will meet at this focus. So image will be here. So if you put the object anywhere in front of concave lens, the image is always formed between focus and optical center. In the case of previous case, when the object was at infinity, the image was formed at focus. Now if the object is placed anywhere in front of this, what will happen? The image will be, position of image will be always between O and F, optical center and focus, and the size of the image will be smaller, always smaller. In previous case you have seen that it was point size, but here you are able to see smaller than object. So this concave lens always forms the image, a smaller image with respect to object. It always forms the virtual and erect image, and the position of image varies between O and F. The range of variation of image, the range of variation of position of image is 0 to F, 0 to focal length. 0 to focal length means it will be formed between focus and optical center. Focus and optical center.